So, have you ever thought about it? Can an AI actually learn on its own? Without a person sitting there guiding every single step. Well, that's exactly what we're diving into today. It's this incredible idea called self-supervised learning. And believe me, it is a total game changer for AI.
I mean, that's the big question, right? How in the world does a machine make sense of, well, everything? All that messy, chaotic data just floating around on the internet. How does it learn what's what without someone literally pointing and saying, that's a cat, that's a dog? It really does sound like something out of a sci-fi movie, but this is real and it's happening as we speak.
All right, so before we can really appreciate how amazing this is, we have to talk about the big problem, the major dilemma AI has been facing for years. And it all comes down to this one thing, labeled data. I mean, for a long time, the biggest headache for AI researchers has been this massive, massive need for humans to label everything. It's like this giant worldwide project of just pointing at pictures and text and telling the machine, this is this and that is that. So, traditionally, you've got two main ways AI learns. On one hand, you have supervised learning. This stuff is super powerful, and it's a big but, it needs a ton of human-labeled examples. We're talking millions of photos, each one tagged by a person as cat or not a cat. Then you've got unsupervised learning, which is cool because it doesn't need labels. It just kind of looks for hidden patterns in the data on its own. But the real problem, the bottleneck, has always been with that supervised method. The sheer cost and time it takes to get humans to label all that data, it's been a huge brake on how fast AI can develop. So what if there was another way, a third option? What if an AI could tap into that endless, endless ocean of unlabeled data that's just out there? All the photos, videos, and text that nobody has had time to label? Well, that's exactly where self-supervised learning, we'll just call it SSL, makes its grand entrance. And yeah, it is a total game changer.
Here's the best way to think about it. Just think about how a little kid learns, right? You don't sit them down with millions of flashcards labeled ball, dog, tree, nope. They just watch the world. They observe, they pick up on patterns. They figure out that their favorite toy, even when it's upside down or half hidden, is still the same toy. That's the kind of intuitive, context-driven learning that SSL is trying to replicate for an AI.
Okay, so this is the crucial part. This is the big idea. With SSL, the data itself becomes the teacher. There's no external guide. The AI model is built to generate its own questions and its own answers. It's creating its own little study guide, its own supervisory signals, right from the raw data. It's literally learning just by digging into the structure of the information it sees.
All right, but how? You're probably wondering how it can possibly generate its own supervision. It sounds a little like magic, right? Well, the secret lies in this really clever idea called pseudo-labels. This is the core mechanism that makes the whole thing work.
So, what's a pseudo-label? It's actually a pretty simple idea. The AI looks at some data, and based on what it already knows, it makes a prediction with high confidence. Then, and this is the key, it just pretends that its own prediction is the ground truth, like a human actually labeled it. It's basically the AI saying to itself, okay, I'm like 99% sure this is a picture of a cat, so for this round, I'm just gonna assume it's a cat and use that to learn more. And then it uses these self-made labels to keep refining its understanding. Now, this whole process usually plays out in two main stages. First up is what's called the pretext task. The best way to think about this is like a self-made puzzle that the AI has to solve. Maybe it gets an image with a chunk blacked out and it has to guess what's in the missing piece, or it gets a sentence and has to predict the very next word. By solving these little puzzles, not once, but millions or billions of times, it builds this incredibly deep, foundational knowledge about the data. Then, and only then, does it take all that wisdom and apply it to the actual task we want it to do, like, say, accurately classifying photos. So let's talk about these puzzles, these pretext tasks. What do they actually look like? Well, this is where things get really creative. Researchers have come up with some seriously brilliant ways for an AI to teach itself. At a high level, you can split these puzzles into two big categories. The first is called contrastive learning. Think of this like a game of same or different. The AI's goal is to learn to pull similar things closer together, so two pictures of the same car, but from different angles, should be seen as similar. And at the same time, it has to push dissimilar things far apart, so a picture of a car and a picture of a dog should be seen as different. Then you have the other approach, non-contrastive learning. This one's a little more subtle. It only uses same examples. The The goal here is just to teach the model to recognize that two different views of the same thing, like two different cropped sections of a big photo, are fundamentally related, without even needing to see a different example to compare it to.
Okay, I know this all sounds a little abstract, a little in the weeds of AI research, but here's the really cool part. You're already interacting with the results of self-supervised learning constantly. This is not some far-off theory. This is the engine running under the hood of some of the biggest tech you use every single day.
I mean, think about it. Ever use a voice assistant on your phone? That's powered by tech like Facebook's Wave2Vec. How about when you type a really complicated, weird question into Google and it just gets it? That's Bird at work. The best image recognition systems out there, they're using models like something called BYO. And of course, the big one, large language models like GPT-3. How do you think they got so good at understanding and generating language? They basically just played that predict the next word puzzle, but they did it on a massive chunk of the internet, over and over and over again. So what's the big takeaway here? It's this. Self-supervised learning is the key. It's the key that finally unlocks the potential of the vast, vast majority of data in the world. We're talking about the 99% of information that isn't nicely labeled in a spreadsheet somewhere. SSL allows AI to learn from the world as it actually is. Messy, chaotic, unlabeled, and just enormous. And that brings us to one last pretty wild thought. I mean, if an AI can teach itself the fundamental patterns of human language, of what things look like, of what sounds mean, just by observing raw data, then what are the limits? Seriously, think about it. What can't it learn?